It started with a gas that refused to escape. The year is 1938. Picture a young chemist in a dimly lit lab, carefully opening a pressurized gas cylinder. He's anticipating a powerful, potentially explosive reaction for his experiment. But instead of a hiss or a blast, there's only silence. He shakes the cylinder. It feels heavy, but nothing comes out. Confused, he takes the risky step of cutting it open. Inside, he finds not a gas, but a mysterious, slippery white powder lining the metal walls. That strange powder would soon be known as Teflon, the revolutionary non-stick coating that would transform the modern kitchen and so much more. And like so many of history's greatest discoveries, it was never, ever supposed to happen. Our story's main character is Roy J. Plunkett, a bright and ambitious 27-year-old chemist working for the chemical giant DuPont. His mission wasn't to invent cookware. His goal was to find a new, better refrigerant. Back then, refrigerators used gases that could be toxic or flammable, so the race was on to find a safer, more efficient alternative. Plunkett was experimenting with a specific chemical gas called tetrafluoroethylene, or TFE for short. He filled several small, high-pressure metal cylinders with about 2 pounds of TFE gas each and stored them overnight in a freezer, hoping the cold would stabilize them for his experiments. The next morning, he retrieved one of the cylinders, attached his equipment, and opened the valve, ready to measure out the gas. But nothing. Not a sound. Not a whisper of escaping gas. The pressure gauge read 0, as if the cylinder were completely empty. Yet, it was still heavy. The gas was in there. Somewhere. So what happened? Where did it go? Plunkett and his assistant were baffled. They tried warming the cylinder, shaking it, even reopening the valve, but it was no use. The gas was gone. Frustrated but driven by curiosity, they decided to do something a chemist would normally never do. They sawed the cylinder in half. As the metal split, a fine, waxy white powder spilled out onto the lab bench. The TFE gas had undergone a strange transformation. Under the intense pressure and cold, the individual gas molecules had linked together, forming long, stable chains, a process called polymerization. Plunkett had accidentally created polytetrafluoroethylene, or PTFE. He began testing the strange new substance. He tried to burn it, but it wouldn't ignite. He doused it in powerful acids and solvents, but it wouldn't dissolve or react. And, most peculiar of all, nothing would stick to it. Not glue, not water, not oil. He had stumbled upon one of the most inert and slippery materials ever known to science. DuPont immediately patented the discovery, giving it the trade name we all know today, Teflon. But this new, almost supernatural material was so strange, DuPont didn't know what to do with it. It was incredibly difficult and expensive to produce, so using it for something as mundane as kitchen pans was out of the question. However, its unique properties soon caught the attention of another, far more secretive project. The world was on the brink of World War II, and the United States was secretly developing the atomic bomb under the Manhattan Project. The scientists working on it had a massive problem. They needed to handle highly corrosive uranium hexafluoride gas, a key component in enriching uranium. This gas was so reactive it would eat through almost any metal or container. Except one, Plunkett's accidental powder. Teflon was the only material they found that could resist the corrosive gas. So, this non-stick material, born from a failed refrigerant experiment, became a critical, top-secret component in one of the most significant and destructive projects in human history, coating the pipes, valves, and gaskets that handled the building blocks of the atomic bomb. Teflon's journey from a top-secret military material to a household staple did not happen until after the war. In the 1950s, a French engineer named Marc Grégoire was using Teflon to coat his fishing gear, making it easier to untangle his lines. His wife Colette watched him and had a brilliant idea. She was tired of scrubbing burnt food from her cooking pans and asked if he could try coating one of them with that same slippery substance. Marc was skeptical, But he figured it out. He developed a method to bond the Teflon to an aluminum pan. The next morning, Colette cooked an egg. It slid around the pan as if it were on ice and slipped right onto the plate, leaving a perfectly clean surface behind. It was a kitchen miracle. The first non-stick frying pan was born, and they launched their new brand, Tefl, a combination of Teflon and aluminum. The idea took off. By the 1960s, non-stick cookware was flying off the shelves in America, and soon, Teflon was in every kitchen, making cooking and cleaning easier for millions. The gas that refused to escape had finally found its home. But the story doesn't end there. Like many scientific miracles, Teflon has a more complicated legacy. For decades, the manufacturing process used a chemical called PFOA. Over time, studies began to emerge linking PFOA to serious environmental contamination and potential health concerns for factory workers and nearby communities. The very properties that made Teflon so durable also meant that these associated chemicals did not break down in the environment. This led to widespread regulatory action and public pressure. In response, chemical companies, including DuPont, phased out PFOA and developed new, safer methods for making non-stick coatings. Today, the Teflon in your pans is made differently. But the story serves as a powerful reminder that even the most beneficial inventions can have unintended consequences. It's a classic tale of scientific genius, accidental discovery, and the caution we must carry as our innovations reshape the world, from a trapped gas in a forgotten cylinder to a secret wartime material, and finally, to your kitchen counter. The journey of Teflon is a perfect example of how some of the greatest discoveries happen when things go completely wrong. It's a testament to the power of curiosity, reminding us that sometimes the most profound breakthroughs aren't planned in a boardroom. They're found in the unexpected results of a failed experiment. Thanks for watching. If you enjoyed this story of accidental genius, do not forget to like this video and subscribe to our channel for more tales of how mistakes made history.